Arden's theorem. See, I know that for any regular expression there is a DFA, and for every DFA there is some regular expression that we can get. So how do I construct a regular expression from a DFA? So now for that I make use of Arden's theorem. Now what does Arden's theorem tell me? Arden's theorem tells if R is equal to Q plus RP, if I have the equation in the form R is equal to Q plus RP, then I can rewrite it as R is equal to QP star, where P and Q are regular expressions. Okay. So now how do I implement this Arden's theorem? This is the statement for Arden's theorem. For Arden's theorem, what we have to do is, now whichever are the states, we are supposed to be checking what are the incoming edges and from where are those incoming edges coming. So I can rewrite it as Q naught is equal to Q naught is an incoming edge with input symbol 1, and because it is the start state I will put plus epsilon. How can I rewrite for Q1? For Q1 there is an input symbol from Q1 itself and another one from Q0. Now from Q0 it is 0 and from Q1 it is 0 plus 1. Now I am supposed to be solving for Q1 because it is the final state. In Q1 I have an unknown which is Q0. So I will solve for Q0 first and then we will see how do we substitute this in Q0. Now applying Arden's theorem, for Q0 we get Q0 is equal to, now I can rewrite it as epsilon 1 star. That is, see here, this is R. If I have to redo this, R is equal to RP plus Q. So I will get my answer as nothing but R is equal to QP star. So I will get epsilon into 1 star. So this is what I have written here, which is nothing but 1 star. So Q0 is nothing but 1 star. Substituting Q0 equal to 1 star in Q1, we get Q1 is equal to 0 into 1 star plus Q1 into 0 plus 1. Now again this is of the form R is equal to Q plus RP. Here this whole thing forms a Q. This is R of course and this is a P. R is equal to QP star. This has to be written as Q0 0. So I will get 1 star 0. So now this is Q and this is P. So Q1 is equal to QP star. I will get 1 star 0 into 0 plus 1 the whole star. And this is my final answer. Now let us see another example for Arden's theorem. Now we have three states. Q0 is equal to, which is the incoming edge? No incoming edge. So just epsilon because it is the start state. Q1. Q1 has two incoming edges. One from Q0. So I will put Q0 0 plus and another one is from Q2 on 0 again. Now Q2. Q2 has one incoming edge from Q1 on 0. Okay. Now I should solve for Q1 because Q1 is my final state. Q2 can be written as Q1 0. Okay. So I can write substituting Q naught equal to epsilon and Q2 equal to Q1 0 in Q1. Q1 equal to epsilon 0 plus Q1 0 0 equal to 0 plus Q1 0 0. Now this is of the form R is equal to Q plus RP. So I can, applying Arden's theorem, I get Q1 is equal to 0 into 0 0 the whole star. As you can see, this is my final answer. And so what is leading me to my final state? 0 and then even occurrences of 0 0, even occurrences of 0. So 0 0 the whole star. With this also I will reach my final state. Even if there are even occurrences of 0 0, that will also take me to my final state. Let us see one more example. Q naught is equal to, I have only one incoming arrow, Q naught with 0 plus epsilon, and then Q1 has two incoming arrows. One is from Q naught on 1 plus Q1 on 1 again. Okay. Applying Arden's theorem for Q naught, we get Q naught equal to epsilon 0 star or 0 star. Substituting Q naught equal to 0 star in Q1, we get Q1 is equal to 0 star 1 plus Q1 1. Q1 is equal to 0 star 1, 1 star. So this is the regular expression for Q1. Since we have two final states, we have to combine both. So I can say 0 star plus 0 star 1, 1 star. Or in other words, I can say 0 star epsilon plus 1, 1 star. This is the final result.